Shall I compare thee to a summer day? I am not speaking about the weather, nor I am quoting Shakespeare Sonnet 18. I'm quoting Mr. Turing as we will speak about computer. In the speaking about computer, I will wish to introduce to you my personal PowerPoint. Please come PowerPoint. He is my personal PowerPoint. His name is Johnny PowerPoint. Let's go. Are you ready? Okay. Many important structures were designed and built in the past without the use of computer, but the cost and the necessary ability for design were greater than nowadays. I was an assistant of Sergio Musmeci, so I know the Basento Bridge history very well. The Basento Bridge was born from a genius mind, and it required a costly model. This is, please show me the slide. This is the first neoprene little model that has been now unfortunately lost. And this one, the second please, the other slide, is the expensive model in microconcrete. The bridge was recently, you can change the slide. The bridge was the subject of a recent paper where there is a contribution of mine for the FEM model. It shows the useful stress distribution that is a prerequisite for minimum weight. Unfortunately, nowadays is a certain reluctance toward computational mechanics in everyday design practice. We often see collection solution according to the method of the Roman Empire, divide et impera. This is an example or recommendation about autoplane mechanism analysis. There is not a general solution. In fact, the next one please. In fact, simple spreadsheets are often used for this simple algebraic model. This is an example. In my work, I will illustrate a topic that you often encounter in everyday design of masonry. That is the analysis of autoplane mechanism in masonry structures. This problem can be tackled with the thrust line obtained through the FEM analysis. Which slide? No, let me see which slide is it. Okay, that's correct. In order to solve this problem, we used a layered degenerated shell element within node with a no-tension material and a smaller crack, rotating crack. To show this method, we applied it to the analysis of an arch. This shows the arch. No, the arch. Is this the arch? This one. The arch. This is a truss line, the arch. Now we see PowerPoint. Let us see the next slide. The eccentricity of the truss line in color. This is through a linear analysis. In the next one, we can see the difference with the results of a non-linear analysis with the no-tension material. The reason is clearly shown in the next image. PowerPoint, please. And now, this is the, are you in the correct slide, PowerPoint? No. This is the thrust line in a dome. In the dome, there is an analysis problem due to the vertical cracks. we have dragged the stiffness matrix to avoid this problem. And now, finally, the next one, please. And now, finally, we arrive to the masonry corner, which is the most tedious problem to solve manually. And this, I think this is the last one. No, this is also, and now this is the computational FAM solution. It is general. The shape of part of masonry in which the truss line is out of the surfaces in red is satisfactory, and the numerical results here not shown also satisfactory. Thank you for your attention. I forgot. My name is Roberto Spagnuolo. Softy, Rome.